Welcome to the next Java User Group Switzerland online talk. Today with Emanuel Trandafir. Hello, Emanuel. Nice to see you.
Hello. Yes. Hey. Nice to meet you.
But before you can start with your talk, it's about consistency and coordination patterns in event-driven architecture. I have some administrative information for you. So at first, very important, without our sponsors, we would not be able to host our events, the on-site events and the online events. So thank you very much for all of our sponsors. In the Bigmarker chat, which you should be able to see on the side of your screen, we have a chat area where you can just paste there or write what you want to talk about. It's a chat for you, the audience. And when you have a question for the presenter, please switch to the Q&A tab. And on the Q&A tab, you can type the questions for Emanuel. We will answer all the questions afterwards, after he has held his presentation. And during the presentation, you can see all questions from all peoples, and you can upvote the questions. And of course, we go through the questions in the order of the number of their votes. And we have a little delay of about 10 to 15 seconds. That is for optimizing the screen for your bandwidth and your screen resolution. So you hopefully have a good experience on your side, no stutterings, etc. Afterwards, you will get an email from us with a link to a feedback form where you can please give feedback for Emanuel and his talk and for the Java user group. And so please check your emails maybe tomorrow. Yeah, and that was the administrative stuff. Thank you very much. And now, Emanuel, can you switch to your screen? Are you ready?
Sure, just give me 1 second. Let me share my screen. Yeah. You already see it, yeah? Right?
Yeah, I see your screen, yes. You can
okay, so let's go to the slides.
Perfect.
Okay, so, if everything is fine, I'll just get going. So hello, everyone. Nice to meet you, everyone. So I'm Emanuel. I'm a Java developer from Bucharest, Romania. I'm an author on Pildung, and in the code, I value simplicity and code that's being intentional. So unfortunately, right now, there's not so much intentional code. It becomes more like a commodity, but yeah. Outside of work, I like doing 2 or 3 sports. I like doing rock climbing, playing tennis, and doing triathlons. And that's about it for this part about me. So let's see. Why have I chosen this topic, and why I wanted to talk to you about event-driven and architecture and all these patterns and everything? Well, I think now with all the AI-generated code, we get we don't spend as much time writing code, so we spend quite a bit of time reviewing code. Review kind of became like a bottleneck. So if we zoom in here, somewhere here, I think we can see a junior developer reviewing code wrote by Opus. Yeah. So now I think there are 2 or 3 important areas where we can use this extra time that we get. And I think mainly is going to be observability, just because we want to observe that all this code and see that it's behaving well. And also architecture, just to stay on top of things and keep everything, nicely structured. And now, also because I'm from Romania, Eastern Europe, I got to see some really bad architecture. So like this is in Constanța, close to the Black Sea. And it's funny that, one of these old buildings was really close to the city center. And during the Christmas fair, they tried to decorate it and make it look nice and festive. and they put some teddy bears on top, and this is what they hope is going to look like, But if you work with legacy systems, you know that we cannot just put like some small nice features on top and expect it to look like that, right? So the actual result was more like this. So this is an actual picture from that place. So, but how do we ended up here? How do we have code that looks like this? This is only a bit of code that I'll be sharing. So this is a Java method which is creating an order for this application, which is handling some e-commerce business case. And this one is in particular is saving to the database an order, and then doing a bit of logic and also saving, like updating the products table. Now, we would like to wrap this into a database transaction, right, to keep everything atomic. But unfortunately, this method is doing a few other things as well. So it is also publishing a message here. And in fact, this message that we are publishing here to the message broker, it's actually a domain event. It's saying that something happened within my bounded context, and the rest of the system needs to know about this new event that just happened, about this order created. Now, then, also in this method, we are also saving something to the file system. Okay. And then it's also sending a post request to a different application, to this loyalty services. So we are also sending this HTTP request, which creates a side effect in a different microservice. And then we are also sending an email. So it's doing quite a few things. I think Uncle Bob would be really not happy with this method because it is doing so many things. But the main idea is that, okay, we try to make it transactional. We try to make this atomic. And then what if something fails? Let's say that sending the email fails. Well, in that case, okay, we will be rolling back the database changes. But what about the Kafka message? The Kafka message is already out. It's sent. And the rest of the system already knows about it. Same for the HTTP request, which is already out, and so on. So today we'll discuss a bit about these problems, right? We have two types of issues here. We have like a coordination problem. We are trying to coordinate all these systems to work together. And we also have a data consistency problem. Yeah, if something goes wrong, we are in a very weird state where other system may know about this new order, but in our database it was rolled back and so on. So that's why we have the consistency and coordination patterns. Now, when I put together this example, I said, well, maybe I'm over exaggerating. Maybe we don't really write code that looks like this, that's doing so many things. But then I remember we often see tests like this with like just a lot of mocks, and then the test itself looks like just a lot of stubbing and then verifying mocks, which can be a hint that we are in fact doing so many, like causing this side effects. Yeah, so that's why we need so many mocks, because there is some sort of IO in there that we are trying to simulate. So yeah, maybe we do have these problems. And looking back here, what was the core, the main issue that we are dealing with, right? Well, the issue that we are having, the main challenge is that we are actually trying to write data to multiple systems, right? To different systems. By write the data, I mean we are trying to update or insert into the database, publishing a message to the message broker, sending HTTP requests that are like causing side effects in different applications, interacting with the file system, and so on. There can be many examples here. Well, I mean, and this is a known challenge that we can encounter, and it's also known as the dual write problem. So it has to do with writing to, I guess, 2 different systems, but we had more like 4 or 5 systems, right? So this is first thing that I wanted to cover, and it's kind of the source, like the main cause of issues that we had in that code example. And it's also like the challenge that we are trying to solve. And we'll explore different patterns to try to deal with these side effects. Now, one simple example, so out of the different cases that we had, like sending the email, sending the message to the message broker, sending an HTTP request, and writing to the file system, the easiest one to deal with is probably the file system, right? So we can also always just delete the file from just because it's just locally accessible. So this is a very simplistic example, and we cannot really do the same with the message broker, let's say, right? We cannot just remove the message from there. But why can we do it here? Well, we can do it here. We can undo something that we did because we have control over this. And we said that we don't really have control over the message broker, but what if we control the consumer application of that message? Can we do something about it? So in other words, let's imagine we are having these two microservices here. The order service receives this request and it saves the order to the database, and then it's publishing the order created domain event. Now the inventory service can listen to this, it can react and do its own bit of thing. It's trying to decrease the stock. And now if something goes wrong here, let's say we are like out of stock, we can publish another message, another domain event to say that, oh, look, something happened, something went wrong here. So for example, this stock unavailable message. Now the order service can listen to this, and then it will need to do something like a compensating transaction, like an operation that will undo what it first did. In this case, it will just cancel the order. So that after this short loop, we'll be in a consistent state again. Yeah. So that now one important aspect here is that canceling the order needs to be idempotent. So we need to be sure that we can retry doing this again and again. If we fail to do it in the first place, we can just try to do it repeatedly until we succeed. Yeah. Now this works, and it's all right. But here, what I don't like about this is that you see this inventory service listens to the order created message channel, so it kind of knows about orders domain, and then the order service knows about the stock and the inventory domain, so they both kind of know about each other in a way. And there's this weird like cyclic dependency almost, right? What can we do to change things a bit so that we avoid this? Well, one option would be to have like another component which acts like a coordinator. So this central component can just tell the other services what to do. In this case, it's telling the order service, look, you need to create an order. And then if everything goes well, it tells the inventory service, you need to update the stock, and so on. If something goes wrong, the coordinator can always go back to the previous steps and send another command to undo something, right? To perform this compensating operation. And of course, there can be multiple components involved into this domain workflow. If something goes wrong down the line, it'll just go to all the previous steps and undo them. So these two were like just two different flavors of the same pattern. And the name and the essence of this pattern is that we go on with our like transaction. So we have a distributed transaction, and in case something goes wrong, we just go back and undo previous steps that we did. And this is also known as the Saga pattern. The definition from Chris Richardson's microservices patterns book is that a Saga is just a sequence of local transactions, and each of these local transactions is just updating its own database and then publishing a message to trigger the next transaction in the Saga. And then finally, if a local transaction fails, the Saga will execute a series of compensating transactions. So in this way, we will be eventually in a consistent state again. Now, we discussed a bit about the dual write, we understand that the main problem is just writing to different systems and trying to keep them in a consistent state. And then we tried to fix this using the Saga pattern, which allowed us to undo things that we did in a previous step. But what were these two flavors of the Saga? So we saw it implemented in two different ways. First of all, we had one of the options was the approaches was this one where we have a coordinator. Well, this coordinator is also known as an orchestrator, and this is just named orchestration. As we discussed here, this orchestrator is sending commands to these components in the workflow. So these can be synchronous or asynchronous. It doesn't really matter so much, but they are not domain events. They are commands. It's just telling them to do something. One of the advantages here is that the error handling is pretty simple. Yeah, so it's simple. It's easy to implement the Saga in this orchestrated environment. Another advantage is that these components are completely independent from each other. So as you can see here, the inventory service doesn't really know about order service, and the order service doesn't know about inventory or shipping domain. So they are completely decoupled. And when I saw this, I was really happy. I said, well, look, this pattern means we don't have any coupling in our system. So I was thrilled about it. But it's not really like that, right? Because what we do here essentially is just to move all this coupling and all this knowledge on the left-hand side to the orchestrator. So now the orchestrator needs to know about all these domains and just do all the wiring that's necessary. Additionally, it's pretty hard to implement a new component here because it's not enough just to implement a new microservice and deploy it, because it'll just do nothing. We also need to update the orchestrator and incorporate this new component within a business workflow. So there are some pros and cons. So as a summary, the orchestration, so an orchestrated environment relies on an orchestrator that coordinates all the components. It tells them what to do, when to do it. It doesn't tell them how to do it. This is still the responsibility of each individual microservice. And all these components, they don't really talk to each other directly, which is a good thing. Okay, so we discussed orchestration, and we saw that it's pretty easy to implement the Saga in an orchestrated environment. Now let's see what the alternative was. So the other approach was more like this. So each service is just listening to message channels, doing its own bit of the business logic that it is responsible of, and then publishing its own domain event. And this allows us to move pretty fast and have this evolutionary architecture where components can be implemented pretty fast. Now, this is also known as choreography. And it's much simpler to implement new components because we no longer have the central orchestrator. Also, because of this, it scales a bit better. and it's a bit more fault tolerant. We no longer have a central single point of failure. Error handling becomes a bit more complex, and we do have the cycling dependencies as we discussed before. So within a choreographed environment, the services are just reacting to events, and they decide by themselves when they need to do something and what to do. Okay, 1 second. Okay, so we discussed the dual right. The problem when we're trying to keep different systems consistent, yeah. We discussed the Saga pattern, which allows us to tackle these distributed transactions. And then we discussed orchestration and choreography, which are just coordination patterns. So they describe the way in which we coordinate all these different systems. Now, until now, when I had this presentation before, my friend said, "Okay, it's pretty nice. Thank you for this, but I'm going to go to work tomorrow, and I need to know what should I use. Should I use choreography or orchestration?" So, and of course, it's not that simple, right? That's why we listed all the pros and cons for each of them. But we cannot just say use one or the other. So maybe one part of our system has this need for a complex error handling, right? So maybe we do want to use orchestration there. On the other hand, for the rest of the system, maybe we still want to take advantage of this evolutionary architecture where we can implement new components faster. And maybe there is choreography is better suited. So we can still use both if we want. So we can use one, the other. We can even use a combination of both. If we do so, the only thing we need to look for is, we just need to make sure that the choreographed side can only interact with the orchestrated side through its orchestrator. But what if we spend too much time just trying to keep everything in sync, just implementing sagas, and just trying to deal with this distributed transactions? Well, in that case, maybe there is a sign that we broke things into two smaller pieces. So there is even a discussion if in some cases we should just stick to just a monolith. And I don't mean that monolith. I mean just a nice modular monolith. So it can be orchestration, choreography, it can be a bit of both, or none in some cases. It really depends on your specific context. Okay, so discussed about these and about the Saga, but we started with this assumption that we are sending the message and then we can react to it to undo what we've done. But what if we are in a situations where we cannot even reach the broker? So what if we are trying to publish this message, but it doesn't even reaches the message broker? So this is our message trying to reach Kafka. Yeah. So it was this example. I'll just take the first part of the code sample that we saw before. So we are receiving into the database, and then we are trying to publish a message. Of course, if we fail to publish the message, we are in an inconsistent state, right? So we have a new order in our database, but the rest of the system doesn't really know about it. One naive approach would be just to try to wrap everything within a database transaction. And the reasoning is pretty simple, is that, okay, if sending the message will fail, I'll just have some sort of exception, which will then roll back the database transaction, and I'm in a consistent state now, right? We do not have the message, but we also do not have the order in the database. The problem here is a bit more. It's pretty tricky to see, but what can happen is that we succeed to send the message to the message broker, and then now that we are in a database transaction, we will commit the transaction at the end of the method when we exit this block. And now we can have some issues here. Maybe we just failed because of some database constraints or other reasons. But if something goes wrong after we already published the message and we roll back the transaction, we are in an inconsistent state again. So we have the order is no longer in our database, but the rest of the system knows about this new order and it tries to react to it. So it's not ideal either. So if we stop here, this is also known as at most once delivery in this context of having database and trying to deliver the message. At most once, it means just that we do not have duplicates, but there's some possibility of losing a message once in a while. Now, in some domains, this is maybe all right, but in other cases, losing a message is not acceptable, right? So, for example, I'm working on financial markets, and we cannot really afford to lose any message. So this is we need to find something better than this. Now we can stop here for a second to tell you like a short story. So I was quite young. I was 11 years old, and my father told me, like, son, you're old enough now. You need to know that Santa Claus doesn't exist. Tooth Fairy is not real, and there's no such thing as exactly once message delivery in this context. So I was pretty upset at the Christmas fair, knowing that Santa is not real, and thinking about this distributed transaction and eventual consistency thing as well. But you need to remember that I'm from Romania, from Eastern Europe, so Christmas fair was looking more like this, and I hope you'll not get scared, but Santa Claus was actually looking like this. So I think the further east you go, the more creepy Santa is. But yeah, anyway, this was 20 years ago. So I was thinking that at most once is not good enough. Exactly once we cannot really have. So we need to go to at least once delivery. Yeah. So this means that we are guaranteed to send a message. We will never lose any message. But the downside is that in some edge cases we might still have some duplicates. Okay, let's see how we can do that. Well, one way is to use this outbox pattern, or the transactional outbox pattern, which sounds really fancy, but it's not that. It's pretty simple actually, and you actually use it every day because it's implemented by your email service. So when I'm trying to send an email to you, the email first goes to this special place, which is also known as the outbox. Then a different service is just taking the emails from the outbox and then publishes, sends them one by one to the intended receiver. So it's just breaking this into two different pieces of execution, let's say. This means that if something goes wrong, if the network we have some network issues or everything like this, we can accumulate more messages within into the outbox, and then eventually we will submit them, send them to the intended receiver. So let's see how we can do this in code, right? Instead of having a single method that does both, saving to the database and publishing a message, we'll break this into two different pieces. Now, what about this outbox? Well, the outbox will be just a new table in our database. If we want to keep them a bit more separate, we can use different schema, but it is important to have this, to use the same database, because we want to make this an atomic operation. We want to do this within a single database transaction. Then we need to connect these two, right? So we'll have like some bit of logic that pulls the messages from the outbox, publishes them, and finally it either removes them or marks them as already published. And that's pretty much it. If we fail to send a message, we obviously will not remove it from the outbox, and the next time this will run, we'll pull the same message again until we'll eventually manage to publish it to the message broker. Now, this also looks pretty good. Looks like we have solved the dual write problem, right? But we didn't, right? Because it's not so simple. So again, this left-hand side here, it's only writing to the database, to our own database. So it's safe. This one doesn't have any issues. It's not interacting with different systems anymore. On the other hand, this bit of logic from the right-hand side, it's still sending a message and then updating the database, trying to remove the published event from the outbox. So we just moved this dual write problem further to the edge of our system, let's say, which can be a good thing, because now it means that this part only deals with the business use case, and it doesn't keep this database transaction open for long. So it's just concerned with this. And then this other bit of logic is more about the infrastructure and about externalizing the results of what just happened. So it's just externalizing publishing the domain events. Now, we said that we still have the dual write problem. It's just later in the flow. What are the implications of this? Well, one of them is that even if we manage to publish the message to the message broker, we can still fail to update the database. And in this case, the next time when we pull the messages, we'll pull the same domain event again, and we'll publish it again. So this is why we said we can end up with duplicates in some edge cases. But it is a trade-off we are aware of. And also it's easier to deal with the duplicates rather than trying to find recover lost messages. So it's better to do it this way. Furthermore, since we are here in the application that is producing the message or the domain event, we can even help the consumer of this message to understand that, look, there is a duplicate here. You can just ignore the second one. How we can do this? Well, it's pretty simple. Within the outbox table here, when we save the message that we want to externalize eventually, we can also add a column which is a unique identifier, which will be, I don't know, in this case, I called it idempotency key. And then whenever we send messages, we can add this idempotency key as a header. Now, if we end up with duplicates, we'll have multiple messages with the same idempotency key. And this means the consumer can use this to deduplicate later on, to say, okay, I already saw this message, I'll just discard the second one. So one disadvantage is that this adds a bit of extra latency, especially here when it comes to publishing the domain events, because we need to pull messages from this database. We can produce duplicates, but we have at least once message delivery in this case. So far, we discussed the Saga, orchestration, choreography, and then we discussed about the outbox pattern, which gives us at least once message delivery. And we said that this, the downside of this is that we can produce some duplicates. Let's see how we can deal with these duplicates on the consumer side, right? So if until now we were talking about the outbox, there's also the inbox pattern for the consumer side. It's pretty similar. So instead of just listening to the message channel and invoking some business logic, we'll add an intermediate step where we are just saving into the inbox table this time. Similarly to the outbox, we'll also like pull the messages from the inbox, invoke the business logic for each of them, and then just remove them or mark them as processed. And we remember about the headers that we added, and especially the idempotency key. Since we are saving the message into the inbox table, we can add this idempotency key as a separate column, and we can create a uniqueness constraint for this column. This way, we delegate this responsibility of deduplicating the messages to the database. If we do this, the only thing that we need to be careful about is that we need to catch any the data constraint exceptions or errors and acknowledge the message. So we can say, okay, I already saw this message. I don't want to get stuck with it. So it's okay to discard it. Now, apart from idempotency key, we can use another header, which is observe that. It's telling us the moment in time when this was first observed. And in some cases, we can try to use this to reorder messages within a given time window, but this is a bit more complex. Lastly, when we invoke this business logic and something goes wrong, we can differentiate between retriable and non-retriable exceptions. So a retriable exception will just keep the message within the inbox, allowing us to retry processing it, whereas a non-retriable exception will just remove it from there or mark it as processed. So we discussed a bit about the dual write, Saga's orchestration, choreography, outbox, and eventual consistency, and then inbox pattern, which helps us implement this idempotent consumers, which know how to handle duplicates. As a short summary, in this software architecture, the hard parts book, there is a chapter about these patterns. The authors are describing this three-dimensional space with three axes that we need to be aware of when we take a decision in regards to the communication between two services. One axis is the consistency, so we want to have atomic or eventual consistency. Then we have coordination, and we already discussed about choreographed and orchestrated environments. And we have synchronous or asynchronous communication. So yeah, that's pretty much it. We started with the dual write, writing to different systems and trying to keep them in sync. Saga, which meant that when something goes back, we just go to the previous steps and try to undo some of them. Orchestration, where we had a central coordinator to orchestrate a domain workflow. Choreography, which is the opposite. It doesn't have a centralized coordinator, but it allows the system to evolve faster. We said that we can use either like orchestration, choreography, or like a mixture of both. We discussed the outbox pattern, which essentially means that we first store the message within our own table before we publish it to the message broker. And we discussed the inbox pattern, which is the opposite. It's about saving the message, saving the incoming message to a table on the consumer side before processing it. So yeah, that's pretty much it. Thank you for listening. So I think I'll stop sharing, or should I still be sharing, or I don't know, Marcus, how?
Yeah, you can. I think you can leave the sharing on. I switched to the camera view here.
Mm-hmm.
So just in case the questions require you to show something. Okay, so now everyone was listening, of course. Now you have time to write your questions. I have already seen the first question here from Reto. He is asking, for the outbooks pattern, can you please share your personal experience with @scheduled versus CDC? In my experience, @scheduled breaks down pretty quickly if we have any serious load.
Yes. So I mean, I haven't really used change data capture. That's why I just shortly mentioned it. Now, with scheduled, so in Spring, I think you can take advantage of Spring Modulate which has like an implementation of the outbox pattern. So that's why we mostly used. Yeah, and basically everything happens through Spring application events, and there is a mechanism to resubmit unpublished events. Yeah, and we used scheduled for that. We don't have like a very big, like just a lot of messages, so we didn't hit these problems really. But yeah.
Thank you very much. I hope that answers the question. You can still ask more questions if you want. We can give the audience a little bit of time to write more questions if needed. In the meantime, I have seen in your LinkedIn page, or on your LinkedIn page, that you are a writer for Bildung. I hope I pronounce it correctly.
Yes. Yeah.
I think it's a very famous platform for Java developers.
Yeah, I hope so. I think, yeah, it's very good also for learning, I think. Just to be there and learn about, like, write about things is really nice, I think. Also, you have a dedicated editor, which goes to your, like, what you wrote and, like, challenges you, which is also very nice.
Mm-hmm. Cool. And regarding this talk, of course, can we have your presentation so we can send a link to the audience from today?
Yeah, sure. You mean the slides?
Yes.
Yeah,
the slides.
yeah. I'll provide the link, and yeah, happy to share it.
That is perfect, because as usual, this talk is recorded, and we will publish it on YouTube and on PeerTube, and we will inform everybody when it's live, and we will send a link to download the slides. So thank you very much for that.
Yep.
Okay, then I continue my little presentation from the beginning, and in parallel, we should check if there are more questions coming in. So, very important, we have a lot of events in our pipeline. The events you see here are all on-premise events in all of our cities, Basel, Luzern, Zurich, Bern, St. Gallen, everywhere. So please join our in-person events. And if you have topics you want to see at the Java user group, or if you have speakers you want to see here, if it's online or on our other locations, please contact us and please write us so that we can organize something. There is a new question from Reto. can you recommend any libraries for the Saga pattern? I have seen the library from Chris, book author, but that doesn't seem very maintainable. Are most people implementing their own?
No, I think that was an initiative at some point. It's very good for learning and understanding it, but yeah, I don't know if that project is maintained. So I think we mostly use the Spring Modulate one, which now in the latest release will have some improvements for this. So yeah, this is what we used. In a previous project, we used to implement our own, but then we transitioned to Spring Modulate, and then here it's pretty much the same. So trying to use this one.
Okay, thank you very much. And another question from Patricia. What is your experience with monitoring these kind of systems? Do you have experience back with that program?
Not really. So we had we didn't have like an exhaustive number of like metrics and monitors, but we had the just trying to see the number of unsubmitted messages also. So another thing that we try to do whenever we get the message, we also like try to publish it a bit faster than waiting for this background job to do it, which can help speed up things a bit. But yeah, like just monitoring just the basic things like the number of messages that are pending to be submitted and things like this.
Okay, thank you very much. For now, these are all questions. So I could see, yep. So back to the slides. Yeah, and as I mentioned, we will publish this recording on YouTube. You can find us very easily with a search of YouTube, or you can, of course, just enter yt.jak.ch, as you can see in the lower left corner, and then you will be redirected directly to our YouTube channel. And when you subscribe to our channel and click the small bell next to the subscribe button, you get an information when we publish this video. And we have not only a channel on YouTube, we are on PeerTube since a few months. It's a federated network. It's compatible to Mastodon. So if you have a Mastodon social media account, you can follow us there. And when we publish a video, you will get a message in your inbox. And to be forwarded directly to our PeerTube channel, just use the domain videos.jak.ch, and you will be forwarded to the instance where we host our PeerTube channel. And please follow us there too. And you can even follow us without an account. If you have an RSS reader or an Atom reader, etc., you can still follow us there. Yeah, that's everything from my side. Again, thank you very much, Emanuel. And
thank you. Thanks for having me. And I'm waiting for the feedback.
Yeah, I wish you all a really nice evening. Hope you learned something new, and you should receive a feedback link for the form soon, maybe tomorrow. And thank you very much. Have a nice evening. Bye-bye.
Thank you. Bye.